Now you've learned how to visualize a detector geometry created by somebody else. You may be eager to learn how to create your own detector geometry. You may find a few methods to define the geometry of a detector in the GDML menu for application developers. The first method mentioned in the menu is to define simple solid like boxes, tubes in C++. GDML provides a graphic user interface written in Java called Momo for you to create your geometry by clicking and then selecting. You can then convert your geometry into C++ code. The automatically generated C++ code can be then embedded into your GDML application. This is a great way to get started with some simple geometry. However, in case of a complicated detector geometry, where the same shape or slightly different shapes are placed in space repeatedly again and again, the graphic user interface is less efficient than a for loop in a C++ program. There are three major drawbacks in programming a detector geometry in C++. The first one is that all C++ program has to be compiled. Say if you want to change a simple parameter in your geometry, like the height of detector, you will have to change your source code, compile it before it takes effect. The second is that your GDML application written in C++ will become bigger and bigger when you add new detector geometries into it over time. The last drawback of a C++ coded geometry is that it only exists in GDML simulation. It cannot be passed as it is from GDML to some analysis software such as certain root for event display or statistical analysis. GDML provides three other methods to solve these problems. However, they only appear in the GDML menu after a long description of how to construct a detector geometry in C++. Their power are largely overlooked. The first one is called GDML. The detector geometry in this method is written in a text file in a special format similar to that of a HTML file. A detector definition in GDML file can be imported into a GDML simulation. A detector geometry defined in GDML C++ format can also be exported into a GDML file. The GDML format can be understood by FreeCAD, an open source CAD software that can be used to create professional technical drawings of your detector geometry for fabrication. It can also be understood by root if this functionality is enabled in your root installation. There is a macro command in Gears called geometry source. It is used to import a GDML file defined in other software such as FreeCAD. There is another command provided by Gears to export existing detector geometries in Gears into HTML file so that it can be used by analysis software such as Root. GDML is a great way for us to pass a detector geometry from one software to another. However, a GDML file is a little bit too complicated to be added manually. HTML shares the same problem as GDML. It is very hard for people to remember all these tags for different elements. That's why Markdown and Wiki are created to replace complicated HTML syntax with much natural and simpler ones. They all result in the same output. GDML also has something similar to Markdown and Wiki. It is called text geometry definition. It is less known than GDML. However, it has been introduced into GDML a long time ago. To define a 10 by 10 by 10 meter experimental hall filled with air in text geometry format, all you need is this one line of code. This is much simpler than GDML or C++. The same macro command, geometry source, can be used in Gears to read a text geometry definition file or a GDML file. In Gears examples detector directory, you can find more text geometry definition files ended with the suffix .tg. To learn more about the syntax of the text geometry file, please refer to the Import ASCII Text Models section in the Geom4 menu for application developers. Remember, one of the advantages of a geometry defined in C++ is that one can put a geometry object in different places quickly with a few lines of C++ code using a for loop. This cannot be done directly in a text geometry definition file. However, since the syntax of text geometry definition is so easy, one can use his or her favorite programming language that involves loop to create text geometry file. Gears provides a few examples to demonstrate how to use shell scripts to construct more complicated geometries, like this and this. The shell script used to create such a geometry is only about 20 lines long. One of the reasons for Gears to be so small is because we use the simple text geometry definition and GDML to replace complicated C++ programming. This dramatically reduced the slope of Geom4 learning curve. This also makes the recompilation of Gears unnecessary in case of some simple changes in your geometry or the creation of an entirely new detector geometry. Another benefit of eliminating hard-coded C++ geometry from Gears is to make it more universal instead of getting tied with a specific detector geometry.